Hey everybody, this is Mr. McKee again with Net 226. Today I'm going to be going over Packet Tracer 11.5.1, which is compare Layer 2 and Layer 3 devices. Alright, for this Packet Tracer, all you're doing is answering questions, so there's no real config grades for this. So if I hit check results, see how check results is locked. Alright, so I'm not really worried about that. What I did though, I downloaded the Packet Tracer instructions and converted those to Word document. So this will be what, if you're in my course, this will be what you'll submit. And I went through here and just marked every place you needed to answer the questions. And there's 19 questions to answer. All right, so that'll be on the submission link in Moodle. All right, and let me make my topology a little bit smaller. All right. So basically, we're just comparing Layer 2 and Layer 3 devices. All right, and looking at our topology, we have a Layer 3 switch, and notice a Layer 3 switch looks like a cube with a circle in the center and arrows going all the way around it, kind of like a clock face. You have those, you have a router, R1, R2 routers, then you have switches, which are more of a flat box or flat square. All right. So in this activity, you will use various commands to examine three different switching topologies and compare the similarities and differences between the 2960 and 3650 switches. You will also compare the routing table on a 4321 router with that of a 3650 switch. It says, note, search the internet for more information, more details about the 3650 Layer 3 switch and the ISR 4321 router. And if you notice in the name of a switch, that tells you how many ports are in it. P, I believe, is... I know this has power over Ethernet, so I think the P is power. And ISR, this means it does cryptography stuff in it for the ISR 4321. All right, so step 1, compare Layer 2 and Layer 3 switches. Examine physical aspects of D1, which is the top left Layer 3 switch, and ASW1. And now it is looking for actually physical. I tried to find a good picture on the internet, but it's hard to get a good close-up picture. But if we go to physical on here, in Packet Tracer, and then click zoom in, you can kind of make out what you're looking at. Now this right here, you have the console and the management ports. Let me look at my switch. Management port should be on the top and console should be on the bottom. So you put a console cable in here if you don't know the IP addressing information. If you want to do a management port where you can only manage the switch from, say, inside your network on this interface, you could make that interface that. For that, you have, I know this is hard to see, 24 ports, and then you have 4 more SPF or small form factor ports. This one right here has 2 SPF plugs already plugged into it, but the two on the left, the 2 empty SPF plugs are 10 gigabit. All right, so it says Catalyst 3650 24 for 24 ports, PoE plus, so it does power over Ethernet, and then it has 2x 10G, which is 10 gig. All right. So these two are 10 gig, everything else is 1 gig. All right, and then ASW1, zoom in on this. All right, so this has all gigabit 24 ports and 2 uplink ports. And I believe, let's see, 36. Okay, and these are your uplink ports. Now, depending on the 2960, it's hard to tell this one, but you could have 1 gig upload ports, or you could have 10 gig upload ports. And also, some of these models have power over Ethernet, but this one doesn't say it does. And more than likely, when you go into the, if I go to privileged exec and do a show run, see, it tells me these are fast. These are actually fast Ethernet ports. So they're 10100s. All right, 24 of those. See, this one's even older than I thought. 24 port fast Ethernet ports and 2 gigabit upload ports. All right, so that's how you tell. If it's 10 gig, it'll say TG or 10 gig. And then if we look at the 3650 under CLI, all right, see how these are gigabit, and notice that these have three numbers. These should say 10 gig, but they don't. So that's probably just a packet tracer thing. Yeah. All right, but that's how you tell. All right, so each individual switch has how many physical switch ports? The 2960 had 26 ports. All right, right there. 12, 24, and then 25, 26. And then there's 3650. Let me zoom in. All right, 12, 24, 25, 26, 27, 28. It has 24 fixed and 4 modular gigabit ports, or SPF ports. All right, and it says, let's see, list the transmission speed of the fast Ethernet and gigabit Ethernet switch ports on each switch. All right, so you have fast Ethernet ports on the actually, the transmission speed of the fast Ethernet is 10, either 10 meg or 100 meg, and the gigabits 1 gigabit. All right, or you could say 1,000 megabits per second. All right, are either of the two switches modular in design? Well, yes, this one's modular, and this one, if you looked at a picture of this on the internet, all 4 of these SPFs would be unpopulated. This just has 2 SPF plugs plugged into it. All right, you can either do, this one has RJ45, but you can also plug in fiber connections there for your uploads. All right, the switch ports of a 3650 switch can be configured as Layer 3 interfaces by entering the no switch port command in interface configuration mode. This allows technicians to assign an IP address and subnet mask to the switch port in the same way that they would be configured on a router interface. All right. So what is the difference between a Layer 2 switch and a Layer 3 switch? A Layer 2 switch makes the decisions to forward packets based on MAC address. A Layer 3 switch is configured with interfaces are configured IP addresses, and you can configure the IP address to use routing protocols just like a router. All right. And we actually have a Layer 3 switch here, but we don't even use the Layer 3 functionality in it. And it costs you a little bit more to get the Layer 3 functionality, usually. All right. What is the difference between a switch's physical interface and the VLAN interface? Well, the VLAN interface is what you do to remote into is configure the switch. You can actually access that with like kind of like on a firewall. That would be your management interface. You know, data is not going to go across the management interface. Kind of like the same thing. All right. At which layers do 2960s and 3650 switches operate? The 2960, since it's a layer 2, operates on layer 2 or data link layer, and the 3650 switch operates on the layer 2 and layer 3, so it's data link and the network layer. All right, so let's see. Issue the show run command to examine the configurations of D1 and ASW1. Do you notice any difference between them? Well, let's do that. There. Let's go back to CLI, and I'm going to actually show run there and do a show run here. All right, distance in configurations. Obviously, if you can see this one, this version of this software is like way newer than this one. That one's 12.2. This one's 16.3.2. Other than that, this one has spanning tree running. You notice this has IP routing turned on. That's a difference. That one has spanning tree. If you notice these interfaces, see these have two, I guess you'd call it 2-digit or 2-section interface names. These have 3. All right, this is your SVI or your LAN 1 interface. All right, it has that configured on it. On the D1, these are actually configured as routable interfaces. They put no switch port in there to turn it into an interface. And another thing, when they refer to switch ports, the where you plug in at, that's actually referred to as a port. If you turn it on no switch port, just like in a router, it would be an interface. All right, so this one has an IP address assigned, subnet mask, no switch port, duplex, speed, auto. Same thing with gigabit 111 and gigabit 112 are configured the same way. And see this one, if these weren't turned on with no switch port to layer 3 interfaces, you'd have to configure the VLAN 1 or SVI interface to be able to control it, unless you had a console cable. All right, everything else though looks about the same, but that's pretty much all the differences. All right, let's see. Do you notice any differences between them? The big difference was one has layer 3 interfaces configured. Try to display the routing table on D1 and ASW1 using the show IP root command. All right, so I'll start on ASW1, show IP root, and show IP root. All right, so you can see it's showing me the directly connected network, and it's connected to what interface, and this one should be connected to this one right here, 192.168.10.1. All right, is on that network, and 192.168.11.1 is on this network. And why do you think this command does not work on ASW1 but works on D1? Well, just think about which layer it operates on. All right, layer 2 versus layer 3. All right, let me close these down. All right, so step 2, compare a layer 3 switch and a router. In the past, switches and routers have been separate and distinct devices. The term switch was set aside for hardware devices that function at layer 2. Routers, on the other hand, are devices that make forwarding decisions based on layer 3 information. They use routing protocols to share routing information and to communicate with other routers. Layer 3 switches, such as the 3650, can be configured to forward layer 3 packets. Entering the IP routing command in global configuration allows layer 3 switches to be configured with routing protocols, which gives them some of the capabilities of a router. Although similar in some ways, layer 3 switches are different from routers in many other aspects. Open the physical tab on D1 and R1. All right, so D1's there. All right, so I got D1 on the left side, R1 on the right side. It wants me to go to physical. So some differences. This has built-in, let me zoom in a little bit. All right, there's your console connection. All right, gigabit 001, 000. You have a serial connection or serial card in there, and you can put another serial card or another whatever kind of card you put in there, a DSL card or something like that. All right, and then your switch does not have that, and it's just kind of like a statically built interface, other than putting SPF ports in there. This is for a backup power supply, that little empty space right there. So that's the differences. All right, so that's pretty much the difference. You can put more cards in this one, in R1. D1 has a bunch of different interfaces. They're both modular in the terms of you can put SPFs in there on D1 layer 3 switch, and you can put different cards in here also for serial connections. All right, so let's see. All right, so do you notice any similarities between the two? You guys can answer that. Do you notice any differences between the two? Obviously, both have interfaces, but differences are one has a bunch of ports, the other one doesn't have ports. All right. Issue the show run command and examine the configurations of R1 and D1. All right, so show run on that one. All right, so this one starts right here. All right, so it started way up here. All right, there's my show run for that one. And show run. All right, so D1's our layer 3 switch. Notice the version, host names, all that's the same. Everything's the same until you get down here. R1 has 2 gigabit interfaces. It has 2 serial interfaces. D1 has 24 ports and 1, 2, 3, 4 extra ports, and you can assign IP addresses to that or just have them as access or trunk ports. And then both can do virtual terminals, V2I lines, and stuff like that. All right, both have the VLAN 1 interface. All right, so that'd be the differences. Which command allows configuration of D1 with an IP address on one of its physical interfaces? You guys should know that one, but let me see where they stated it at. All right, so to answer that, shows right there. What interface? What command you put in there? All right, use the show IP root command on both devices. Do you see any similarities or differences between the two tables? All right, so similarities. Let me look at this thing too. All right, some of the similarities right here. Directly connected interfaces are shown on each. All right. And then this shows actual local interfaces in its IP address. Notice the /32 CIDR. All right. So a lot of the same, but some little differences there. So on a layer 3 switch, you'd have to look up here and see the interfaces. All right, show IP root. All right, now analyze the routing table of R2 and D2. All right, so we go to R2 and D2. And I can already tell right there, if you see that law message, that should tell you something that's running. Show IP root. All right, so this is D2 is my layer 3 switch. R2 is my router number 2. All right, let's see. What is present now that was not present in the configuration of R1 and D1? Well, you should be able to notice that right there, and you should be able to understand what that is. All right. But up here, when in doubt, just look at it has like the little key up there that tells you what it is. All right. All right, we answered that. Which network is the routing table of D1 that is learned from R2? D2 that's learned from R2. All right, so it learned that one. Or actually, yeah. That interface, it learned this network. All right, verify the topology. Each topology has full connectivity by completing the following tests. So ping from PC1 ping PC2. All right, and our first packet should time out. And if we did it again, it'd go right through since it's done an ARP translation. All right, PC3, PC4. Paste that in there. All right, that worked. Do it again. Goes right through. And then finally, what does it say? From PC5 to PC6 and PC7. Let's do PC6 first. And what's PC7? 11.10. Alright, so we're pinging PC6 first. Alright, that went through. Do it again. Goes right through. Alright, then we do 11.10 for PC7. Alright, that goes through. And finally it goes through. Alright, so we're good there. Alright. In all three examples, each PC is on a different network. Which device is used to provide communication between networks? Well, those right there. Just remember, network to network has to have a router. Alright. Why are we able to ping across networks without there being a router? Well, because you have layer 3 interfaces. Alright. We say that routers are layer 3 devices and conventional non-layer 3 switches are layer 2 switches. However, we can assign an IP address to a management interface of a layer 2 switch. How is this possible if switches are layer 2 devices? Well, the reason you have a SVI is so you can easily manage the configuration of a switch. You don't actually, it doesn't actually send any data across that switch. You just use it for configuration purposes only. All right, and that is it. All right, not any really configurations on this lab, just kind of like figuring out what's what. And if you go on the internet and find some better close-ups of layer 3 switches and routers and layer 2 switches, you guys can take a look at those. But I looked all over the internet, and they're kind of like hard to zoom in on, or they're, you know, like different vendors selling them, and you do a close-up if you click on the link, but then it goes back down to regular size. It's kind of hard to view. So I just left it at looking at the packet tracer examples. All right, that's it. Thanks for watching, and I'll be back with another video shortly.